Jay's Metals has determined that when X 100 storage cabinets are built, the average cost per cabinet is given by C of X equals 0.2x squared minus 1.3x plus 3.4025, where C of X is in hundreds of dollars. What is the minimum cost per cabinet, and how many cabinets should be built to achieve that minimum? We have a quadratic function, so in order to find the minimum, we'll be looking for the vertex of the graph of the function, and in order to find that, we'll complete the square. So let's start by factoring out a 0.2 from the x terms, and we have 0.2 times x squared minus, then if we take 1.3 and divide by 0.2, we would find that that would be 6.5x plus 3.4025. Now to complete the square, I need to take half of negative 6.5 and square it. We'd see that 1/2 of negative 6.5 is negative 3.25, and negative 3.25 squared is 10.5625. This work we'll take this number and add it in order to complete the square. Now we use 10.5625 to complete the square. We need to add inside the parentheses 10.5625 but we can't just add it in there. We need to subtract it back out to give us the effect of just adding 0. So essentially I've added 0 to this, I haven't changed it, plus 3.4025. Now I only need this much in my parentheses, so using the distributive law, I will remove the rest from the parentheses. I have x squared minus 6.5x plus 10.5625 in the parentheses minus 0.2 times 10.5625 plus 3.4025. Now we're just about finished because I can now factor 0.2 times x minus 3.25 squared. 3.25 is the square root of 10.5625. Then if I calculate this, I get plus 1.29. Now I can read the vertex from the graph. It's 3.25, 1.29. But since we're dealing with a real problem, let's write in the units. The vertex is 3.25, and that stood for 100 cabinets. So 3.25, 100 cabinets, and 1.29 $100. And that's important because we don't want to say just 3.25 cabinets. 3.25 is 325, 1.29 is 129. So I can state that the minimum cost, and this would be the f of x coordinate here. The minimum cost is $129 when 325 cabinets are built.